Okay, students, in this video we are going to discuss one important property that before arriving to the conclusion, I would like to ask you, what is A plus A transpose? That means we have to simply add these two matrices. So if you want to add these two matrices, see A is this, the A transpose will be calculated by interchanging rows and columns. So rows will become columns and columns are going to become rows. Diagonal elements are going to remain same. So we are just adding all corresponding elements. In this process, definitely diagonal elements are going to be doubled up. So 5 plus 5 will be 10. Minus 1 plus minus 1 will be minus 2. 8 plus 8 will be 16. This 2 is going to add to 0. This is becoming 2. 1 plus 2 will be 3. Corresponding elements we are adding. Second row, we'll add it up to second row. 0 plus 2 will be 2. Minus 1 that is added up. 3 plus 1 will be 4. Then 2 plus 1 will be 3. 1 plus 3 will be 4. So this is how we have obtained the A plus A transpose. We can see that this element and this element are exactly same. Similarly, we can see that this element and this element are again same. We can also see that this element and this element are exactly same. So across the diagonal, about the diagonal, we see these diagonals, we can see the elements are symmetric. And now if you calculate, suppose this matrix is, say this matrix is X. This matrix is equal to capital X. Then what is X transpose? To your surprise, you note it down that this X transpose is itself only, because the first row and first column are exactly same. So we are going to get the same matrix. This means that A plus A transpose is always a symmetric matrix. A plus A transpose is always a symmetric matrix. Now what is A minus A transpose? A minus A transpose. Simply you have to subtract the corresponding elements. So 5 minus 5 will be 0. 2 minus 0 will be 2. 1 minus 2 will be minus 1. Then second row minus second row. 0 minus 2 will be minus 2. Minus 1 minus of minus 1 will be 0. 3 minus 1 will be 2. Then third row minus third row. 2 minus 1 will be 1. 1 minus 3 will be minus 2. And 8 minus 8 will be 0. If you calculate the transpose of this matrix, then you will see that you are going to get negative of itself. Also, using the definition of the skew symmetric matrix. What is a skew symmetric matrix? A skew symmetric matrix, I'll just recall the definition, is seen that a skew symmetric matrix is that matrix whose transpose is equal to negative of matrix. Do you remember this notes? Here I have told you that every skew symmetric matrix has diagonal elements 0, and about the diagonal elements, the elements are oppositely signed. If this is 5, this will be -5. You see the location and reverse it. The first row, third column element here will be negative of the third row, first column element. Similarly, the first row, second column element will be the negative of this. That means second row, first column element. Similarly, the third row, second column element will be the negative of the second row, third column element. So Aij is equal to minus of Abi. Ith row, jth column element will be negative of jth row, ith column element. So this is the property of skew symmetric matrix. You can identify it like this. So in the same way, if you consider this particular matrix, here they are oppositely signed about the diagonal elements. -1, 1, 2, -2, 2, 2. Like this you should see these diagonal elements are all 0. Hence such a matrix is a skew symmetric matrix. Skew symmetric matrix. So we have seen through this discussion that if you take any square matrix, then if you find out its transpose, then A plus A transpose is symmetric matrix and A minus A transpose is a skew symmetric matrix. Okay, so I'll continue this discussion in the next video. Thank you.